Remember the bounded stack animation we saw in the first video? You push things onto the stack and you can only remove them in reverse order. Well, that is absolutely true for stacks. But sometimes a stack is not a stack, really. So when is a stack not a stack? Answer: when it's an iterator. In its simplest form, an iterator just loops or iterates through all the elements of a collection and gives the client access to them one at a time. Typically, you don't want to modify the collection while you're iterating over it. It's possible, but it's usually not pretty. So we're going to confine ourselves to iteration that does not modify the collection. For example, suppose you wanted to print this bounded stack. If you had an iterator that allowed you to access the bottom element first, then the next element, then the next element, until you finally got to the top element, printing the stack would be easy. And remember, you're not actually changing the stack. The stack stays the same. Iterators can be abused, but if you use them carefully, for example, if you treat them as read-only one-at-a-time accessors to all the elements of a collection, they can work well for you without causing you headaches. When you pop elements from one stack and push them onto another, here's what happens. The receiving stack ends up in the reverse order of the sending stack. But what if you wanted to copy the elements of one stack to another? You don't want the bottom element of the first stack to end up as the top element of the second stack. You want the elements in the same order. In fact, it's not terribly hard to do this. You would just need a third temporary stack. But with iterators, it's even easier. You iterate over the first stack from bottom to top, and as you access each element, you make a copy of it and push it onto the second stack. Here's what this looks like. Now suppose you wanted to reverse a stack. We don't want to put the elements of a stack into another stack in reverse order. We want to reverse the elements of the same stack. Again, you can do this with 3 stacks, but you can also use a combination of the operators we've already seen. First, you create a copy of the stack using an iterator. Then you clear the first stack. Clearing a collection is usually a lot less expensive than taking everything out of the collection one by one. But we'll leave that discussion for when we actually implement the clear method. Finally, now that we have the elements in the original order in a different stack, we can transfer them to the original stack by a series of popping and pushing, and the elements will end up in reverse order. And that's it. I'll see you in the next video.